Okay, so I think it's recording. Oh, it is recording. Cool. I think it's recording. It's
recording even in the screen.
Oh, this is questions. Thank you for coming. All right. Okay. Ready? All right, thank you for coming. Our presentation is on disaster situational awareness for our presentations for New Light Technology. So, defining the problem. Each day, there are disasters that affect millions of people across the globe, from floods, tornadoes, hurricanes, and fires. But currently, there is no one-stop shop place for disaster responders and people to go to find the most relevant news for their disasters. So in terms of our deliverables, we wanted to have open source code that allows for search of big data through a bunch of articles to find the most relevant ones. We wanted to be able to have that code flexible so the user can type in a specific keyword to find the most relevant articles to them. Next, we wanted to have disaster-specific web pages so that if a person wanted to go in and search for wildfires, they can go and search everything about wildfires in one convenient location. And these results pulled up the title, the abstract URL, and the photo of the articles that were relevant to the user. Now, in terms of data scraping, we had a couple options that we wanted to explore. We had News API, Bing News API, and the New York Times API. We ended up going with News API because the return was a JSON dictionary file that was able to pull the title, abstract, and photo, which met all of our deliverables. Now, in terms of data collection, News API did have its limitations. It only scraped news from the past month unless you're willing to pay $500 a month, which I don't have. And also it limits the number of scrapes to 500 for every 24 hours. Now, as you can see, there's 3 of us, and if we can do math, that's 1,500 articles every 24 hours. And we decided that wasn't the most feasible case. So at this point, we'd like to take the opportunity to thank the past groups who did this project, because we did use some of their articles in order to expand our search. As a result, our database was able to finally have a collection of articles of 428 sources and over 10,000 articles. Now, for model selection, we also had a couple options. We could do a sort by relevance with a train test split. We could do a content-based recommender system or a search engine with Word2Vec. We ended up eliminating relevance with the train test split because the only real way to achieve that is to manually label the data. And when we looked at past projects, the majority of their time was spent physically labeling the data relevant or not relevant. A content-based recommender system was very plausible for this, and we actually did use components of this. One of the downsides of a content-based recommender system is that you need a baseline article in order to search for similar articles. And then the search engine with Word2Vec is the one we chose, but we end up using content-based recommenders and the search engine with Word2Vec to achieve our model. Now, the search engine works like this. A user inputs a query such as California wildfire. The Word2Vec engine then splits that search term into 2 different words, so California wildfire. It then uses most similar words to find the most similar words for each specific search term, and then appends that to a list called search term. Then that search term list is compared to another natural language processing attribute that we used on all the articles within the data frame from the NLTK package rake, which extracts keywords from the content, title, and abstract. We compared that with a list of keywords from the original search term, and if it met a certain threshold, it would return that article with the relevant results. The way the recommender system works is that a user likes a specific article, and after the model determines that the content of that article, it returns articles based on that. And Victor will go into the specifics of how the content-based recommender model works.
So this slide shows you how the content recommender works. Basically, the content recommender is which the item which is based on the the similarity of the specific items. And more specifically, it computes pairwise similarity scores for all items in the data set. So this slide illustrates how we use it. So we took three columns from the original article, which are titled content and description, and we contained them together in a common article, which is called common. We created a new column which is called all text, and then we computed the TF-ID award letters for each document, and received the metrics which row of this matrix represents a document, and which column of this matrix represents a word from the all text vocabulary. So having this matrix, we were able to compute pairwise similarity scores for articles, and then eventually when we need to recommend to recommend the most similar documents, we sort the documents by the similarity score with a particular article. So, yes, so.
All right, so now we're gonna show you the website where all this shows up. And all right. Okay, so basically this is the homepage of the website where we use the recommender based on. We actually build the homepage after building all the separate disaster web pages, because by using the Word2Vec search engine, we got the articles that were more similar with the specific disaster name, like wildfire, tornado, flood, and the others. And based on the first article that came up for the specific disasters, we used the recommender to get the two most relevant articles to that one, to get them in the homepage as a summary, so that we have a shorter homepage giving us the most relevant articles. And then if you wanted to get more in depth in one of the disasters, you would go in the specific one. So we have wildfire, we have 3 news for tornadoes, we have floods, earthquakes, hurricanes, and blizzards. The thing is that we are in a time of the year that there are not many news about blizzards. And since we only had the chance to scrape for October, all of the news we got from Blizzard were from Blizzard Entertainment. So there was nothing of disasters. So we just inputted that there are no recent news about blizzards right now. So for example, if we were to go into wildfire, this will show some more news. This has some pictures, and it describes what the news are about. And also we have, if you click the name of the website, which would be the author of this article, this will get you to the New York Times main page. If you were to click on the title of the article in the web page, this will take you to the actual article in the New York Times website. And this happens with all the, well, mainly all of them, because there are some that actually don't have a link anymore, like the website is not working. And I think in earthquake this happens. So here you can see like there's no author, and if we click here, there's 404 because the website doesn't exist anymore, which also doesn't give us the image because the image link is broken. But we can still get the news of what happened with the date. Mainly this happens, we found out this happens in the web pages that are not big companies like the New York Times, which maybe have like a bigger place to store all the data and have more news for more time. And some of this, like for example, let's see, this one here, this 6.7 is the same as up here, but they're not exactly the same because both are reposts from an original source, but they're in different pages. And then, well, we got our news from News API, so there's also a link that gets you to the News API webpage because this was a requirement of the News API terms. And also we have our README is here in the webpage too, which has some pictures and all of our work explained. And at the end, we have some sources again of what we used and the previous groups that did this project that we got information from. And for the most fun part, this search here actually gets whatever you write in there and outputs a variable into Python and uses that variable to get into the search engine to process our, we call it megadata, which is the combination of all the disasters in one data frame. And this will search for the most relevant to the words that we're using. It actually needs to match. We have a list already for each of the disasters. So if you input wildfire, it's going to give you a list of all the wildfire terms, and it needs to have at least 7 words for this to get the article out. So if it matches in 5 words, it'll not show up. So in that way, we get the most relevant articles to what we're writing. So for example, if we were to write wildfire California, this takes a little bit, which got out of the HTML code into as a variable to Python, got worked in the search engine, then a CSV data frame is created, and then we output the data again with the news that are related to whatever we were searching for. So we get some more news. And then I'm just gonna search Blizzard so that you see what happens, which is why we didn't get any like relevant things. But basically, if we were to do this probably in January or February and scrape the news again, we might get a lot of recent news for blizzards. And yeah, that's it. And now change to the.
So in terms of next steps, we would like to scrape data from other sources. We'd like to include Twitter data as well as data from other government websites such as FEMA, which provides real-time updates on major disasters. Because it'd be nice to, specifically for the user, to have multiple data sources to make their own determination as to what's going on in the disaster. We'd also like to pair traffic data to find the best evacuation routes, specifically during major disasters like hurricanes that you know are coming. It'd be very nice, specifically for the user, to have a one-stop shop place to have all the data and all the information that they need to get themselves and their families out safely. And lastly, we'd also like to include real-time web scraping. As you probably saw, the latest articles that we had were from October of the 29th. So if you wanted any more news after that, then you're out of luck. So we'd like to include a real-time web scraping component that would refresh whenever the user had a specific search term. So it would scrape the most relevant articles right up to date. Oh yeah.
And then talking about what Nathan is saying, but in the website, we were thinking that if we had live information and this would be working on a server, it would be nice also to, from the idea of getting information from Twitter, maybe getting the relevant tweets in a live feed at the side of the of the web page, which we have no idea how to do. But it would be nice to learn and have that so that people can actually see what people are tweeting about of the news they're interested in.
Anyway, thank you so much, and questions?
You said that like for each disaster, you kind of had predetermined those search words.
We had a specific CSV for the top 5 disasters: blizzards, tornadoes, hurricanes, wildfires, and
No, I think what he means is that when we do the search engine, we have a list of words that we want to pair up with the news, additionally to the.
oh yeah, we don't have that. Actually, if you search Kardashian in our search engine, articles of Kim Kardashian will come up. So yeah, so it's not restricted to a specific list of search terms.
But in terms of like the sections on the page when you start, those are like.
We have like all the data separated for each of the disasters, and also the combined one. So what we do is just focus on searching news in the specific CSVs first with the search engine by inputting just wildfire. So this gets the most common words in a list and uses that to get the most relevant articles. And of those words, those most relevant words plus the words you're inputting for the search, it looks to match those inside with the combined title, content, and description that Victor was talking about, so that we get the article that has at least 7 words. If we get no articles, then it'll go to 6, and then the limit is 4. But then if nothing comes up, like in Blizzard, for example, we just get an output that says there are no articles. And then for each of the specific pages, we did this in Jupyter Notebooks to get the CSVs already out, because it would be just the same as have the code running for wildfire, since our data is not live right now. So we would always get the same data, but it will take a bit more time to load each of the pages. So which is why we got the information in a CSV and loaded in as we instantiated the models and the page for this to work before. So now the loading is a lot faster. But then after, like, the next step we did is, once we got that, we used the first, for example, this California fires live updates, strong winds may expand blazes. So that's the title we used for the recommender to get in the homepage, that first title, and then the other 2 that were the most relevant.
So the recommender allows is selecting the first.
It's the homepage.
The recommender takes, this is the recommender takes this title and searches all of the other news articles that are 0.09 or lower in cosine similarity. But if we got all of them, we would have what we had initially, which is a really long homepage. So what we did is just take the 2 or 3 most relevant and put them in the page.
I'm curious if you thought about like as a next step, like how could you make this product better if you have like more user data, like if say everyone that is on the site has
I was planning to build that and make comments. It just wasn't that easy, and we didn't have any more time to do it. I actually have a video waiting to check how to do that. I already have it in my computer, and I will probably try and do that after we finish all this, or if I have time during the next weeks. And I can if you want, after we finish all the presentations, I can go over the code for the webpage so that.
I'm more asking like conceptually, like, speak on like how having actual
Yeah. So with specific disasters, you're going to want to see what affects you geographically the most. If you're in San Francisco, you're obviously concerned about wildfires, but you want to see mostly how smoke is going to affect you from the Kincade fire. So if you were a user, we would expect you to put in like a zip code to determine your specific location, and then get news surrounding your specific location, so that it's the most geographically relevant, not only disaster related articles, but also location specific articles as well.
I was thinking also like, I was just like seeing what people have recently looked at, and like be a way to advance.
Oh yeah.
That's obviously like requires some like sophisticated site engineering. So.
And it will also be cool because we would get the recommender to a next step, because then we could also do like Netflix and recommend to people whatever is closer to what they're originally looking at.
You could probably have like a what's hot kind of feature where you see like the view counts for the most relevant articles and have that displayed on the main page, so that it's like, oh, many people in California, or based on your user specific profile, are looking at this article, you might like this. Yes?
Is there any trustworthiness of news source built into this? I don't know much about News API. But like, do they like vet news sources?
They do not, and that's another API that I was looking at. Summarize Bot API does that. It's a news article API that is similar to News API, but it filters for fake news and has a little bit more rigorous check on it. We're building it off of News API because it fit most of our deliverables initially, and we scraped the data like early on in the project. And it also fit with other people's data as well. But that would be another next step. But even more, when people were doing, when we were testing our search engine, the most returns were very similar news sites, such as New York Times, Reuters, CNN, pretty trustworthy sites. And so we didn't really get too much of the fake news. There was a couple weird sources, but in reality, it wasn't that big of an issue.
I would think also that if we had the time to build this live, probably we would find a way to make a list of the most relevant news companies and use only those, or at least try to remove the reposts and others where people just comment anything and probably it's not really that relevant.
Yeah, I think there's a lot you can add, and this is like really awesome start. And it seems like you guys like really built on the previous works as well. It's really exciting to see the product and also like learn about software and data science and things.
It was great. It was a pleasure working with both of them. I think we had a really good team together, and I don't think we could have done it without Aldebaran. We had critical components. We each did a really good job, I think, in our own areas. And it was just a pleasure working with both
of them. Sure. It's a very heartwarming end to a great project.
To the disasters.
Yeah.
Then stop.